Okay.
All right. Good evening, everybody that's in here and everybody online. Kwesi Daniels, I'm the chair of the Department of Architecture at Tuskegee University. And today's talk, we will be talking about Sustainable Architecture 101. We have one expert in the room, so please fact check me if I say anything that doesn't seem to be in accord. But we'll be talking about Earthships. I've been studying Earthships for probably about 13 years now, but I've been studying sustainable architecture since about 2003. And I had a recent opportunity to go to the Earthship community, and I mean, I was just blown away. It's like one of the most awesome experiences I've ever had. Really seeing how it operates, and as far as I'm concerned, it's really one of the best examples of sustainable architecture, like on steroids. And so what I'm going to be doing is having a conversation about sustainability and architecture through the context of the Earthship, because as I was thinking about how do I prepare for this conversation, given that we don't have architects in the room, but we have people who have an understanding about sustainability, I figured let's talk about something that's local that you probably have heard about, and we can couch that conversation within architecture to see how all that plays out. So as I mentioned, we'll be talking about, the title of this lecture is Sustainable Architecture 101, and we'll be talking about Earthships. So does everybody see it? Because I'm not seeing it show up here. Correct?
No, they can only see the class.
Okay.
And they're asking about if there is a PowerPoint.
All right, so I'm going to wing it while we wait for it to show up. So sustainable architecture. So let's first just talk about architecture and how I define architecture. When I think about architecture, I think about it as a way for cultures to kind of put their stamp on the fact that they were here. And so when we talk about sustainable architecture, it's about the way that you allow architecture to put your stamp that you're here, and you're also engaging and connecting with the environment, you're connecting with society, and you're putting forth that culture. And within the sustainable argument, there's the triple bottom line, so and so. So there is a need to understand the financial aspects of it. So one of the things about sustainable architecture is this idea of closed loop. Closed loop is basic understanding is that you have waste that you produce, and that waste will become an input into another system, and then that system will produce a waste product, and that waste will become an input into another system, and then you keep that cycle, and it becomes a closed loop. That's how you get that closed loop design. And Earthship is the epitome of the closed loop design. Earthship has 6 main principles. Build with natural and repurposed material, thermal, solar, heating and cooling, solar electricity, water harvesting, contained sewage treatment, and food production. So I'm going to go through all of these so that you can see how these all come together, but understand that as I'm having this conversation, I'm really going to be couching it within the conversation of sustainable architecture and some principles within sustainable architecture to kind of show you how the Earthship ties into how the Earthship is the epitome of sustainable architecture. So I'm also making the assumption that everybody knows what an Earthship is. All right, I'm making the assumption that everybody knows who Mike Reynolds is, and so I don't have to go into all that detail. So I'm jumping right in. If you don't, definitely do some research or right now as we're talking to connect yourself with it. So the first principle: building with natural and repurposed materials. So repurposing materials is a really strong aspect of sustainable architecture. And so we have this image of a quilt. Everybody's seen a quilt, right? So the quilt is like the perfect example of repurposing materials, because historically the quilt was a piece of jacket, and a piece of sweater, and a shirt, and these elements that they contained a memory, they contained an element of your culture, your family, and you cut those pieces out and you put this quilt together, and you repurposed all those because you weren't using it any longer, and you repurposed it so that you can now keep yourself warm, or from an architecture standpoint, you put it over the windows to keep out drafts. And so the value of what the Earthship does is the Earthship uses tires as one of its main building materials. And the ones I'm speaking about are the ones that come out of the Earthship Academy. They use tires as their main building material, and they use reclaimed bottles as their primary building material. And so to begin to understand how that's sustainable, you have to realize what's happening. All right, so tires and bottles, they're a waste product that we have challenges getting rid of. So tires within any community, you'll find that these will be short dumps. Oftentimes, the short dumping is where you kind of just ride along and drop the tire off on the side of the road, or they're sent to landfills, and they're very difficult to get rid of. And so with recycling of bottles, 80% of water bottles are not recycled. And so the fact that you're taking water bottles and you're plugging them into a new building construction, becoming a building material, this is not what they initially were designed for. They were designed to carry water. But now you're plugging them into a building, a wall, in order to create a wall that forms the Earthship. And you're also packing tires with dirt, which we'll talk about what that does from a thermal standpoint. And you're creating this wall, that's this enclosure that creates this enclosed environment for people to live. And so it looks like this, where you have people that are packing bottles in between, and you have tires in the back that they pack with dirt in order to form the wall. And then you also are repurposing materials on the interior of the space. And so the repurposing of materials and using local materials, you have adobe wall floors, and the material within the doors will be repurposed wood, or depending on how that Earthship is being created, they may actually find an old door and repurpose it. But the other thing that's really beautiful about this is, so you're getting repurposed glass all through here that's been cut and has been put into this wall to create very similar to stained glass. It's just this old glass that's been repurposed and put into the wall, and the colors that are in the glass are now creating these really beautiful experiences inside that space. So the next thing we'll look at is the thermal solar heating and cooling. And first thing we'll look at is the thermal mass. So we start talking about that. That's a passive system. Passive systems, there are passive systems and active systems. Passive systems within architecture are those systems that you don't have to do anything. It's going to operate, and you'll see what I mean by that. And then you have active systems. Those are systems that are mechanical systems. They're systems that you have to provide some sort of energy in order for it to operate and to do whatever its purpose is. And so thermal mass, I have an image of, what's this? If I know what this is.
Shed.
It's a shed. This is a shed, it's storage. We store things in this. So what you want to think about when you think about thermal mass, it's a storage. It's an enclosure that you're containing its mass, and it's containing the thermal properties. Sun is beating in there. So in essence, you're storing sun inside of a thermal mass. So why is that important? So thermal mass is a wall, or it's an element that has thickness to it. And within a normal day, if you don't have a thermal mass, you're going to get peaks, and they're going to have a lot of fluctuations, peaks and valleys. As the temperature changes, the temperature inside your space is going to go up and down. As the temperature outside, temperature inside your space is also going to go up and down as a result of that. As a result of the fact that you don't have a thermal mass. Now you can insulate that wall as well, but the thermal mass also assists you with also reducing the fluctuation of temperature. And that's what you see right here. Although the temperature, there are peaks and valleys, they're nowhere near the peaks and valleys that you get here. It becomes a pretty consistent, pretty consistent temperature throughout the day because of that thermal mass. And you can see on this side, the values of the volumetric heat capacity of a material. Air has 1, glass, wool has 11. But you get over here, here's ram to earth. Ram to earth is the term for taking a tire and pounding dirt inside that tire. You're getting 1,800 is the volumetric heat capacity of ram to earth. The only thing that's greater than that is water. So by having a thermal mass, you're able to contain a lot of heat within this enclosure. And the value of that is that as the temperature swings, that heat eventually is given off. So if the thermal mass had heat that was up to 80 degrees, then as the temperature drops below 80 degrees, that heat starts to dissipate and come on out because heat wants to go to the lowest pressure. And this is what that thermal mass looks like. And so they take tires and they pound the tires and they fill them up with dirt, pound the tires and fill them up with dirt, and that's how they begin to form the walls in order to create the earthship. All right, so the next thing you want to look at, does anybody know what this is an image of? Sunbathing. Intelligence, I love it. So sunbathing.
Trick question.
I was gonna say Gidget.
So thermal solar heating and cooling. You know, when you sunbathe, you're not trying to get in the shade, are you? Hopefully not. You're not going to get a really good tan, right? So when you're sunbathing, you're looking for the optimal location in order to take advantage of all that radiation that's coming from the sun. Well, that's the same concept when you're dealing with solar orientation. What this graph shows is based on where your windows are located within a building, if it's on the south side, which is red, if it's on the east and west side, which are your green, and then northeast and northwest or southeast and southwest will determine how much heat gain you're getting. So this is basically saying, you know, if I'm on the east, my body is turned in a direction where I'm not getting as much sun onto, you know, the full body. It's only like on one side, so you kind of walk around with this half a tan, you know. But if you're on the south side, so you're positioning your body right directly so that the sun, you're facing the cardinal direction south. The sun is now going to beat down on you, and you're going to get a nice full turnover in the backside of your body. So how does that relate to architecture? So we all know that the sun rises in the east and it sets in the west and it goes across the south and northern hemisphere. And so by having your southern orientation with a lot of windows, you're able to get all of that heat gain beaming into that space. And so if you have a thermal mass, I don't have it in this presentation, but it's called a trom wall, or if you have an earthen wall that also acts as a thermal mass, that sun will beam into the building and it will heat up that floor or heat up that trom wall, and it will allow that temperature to dissipate as the temperature starts to swing and stuff to happen. And so just by orienting your windows, you can see if I orient my windows due south, I get a lot more solar radiation throughout the day than if I have them southeast, southwest, or within the north. North, you get no solar exposure. So there is no solar radiation. You're just getting ambient light that's coming in. It's actually heat lost rather than heat gain. Yes?
Sorry, is horizontal like a skylight?
It's just saying that it's just saying that it's flat.
Oh.
The other active system that they have is a cooling system that I thought was really awesome. This was something I didn't see in the literature and in the things that I read about. So it was like great when you go and they're like, if you want to keep it cool, like open up the cooling tube. Oh man, this is great. Air conditioning, I don't have to plug in. So they have a cooling tube right here that is the same concept, that if it's warm air out here, warm air and cool air, they want to replace each other. And so by opening it, you're able to get this transfer of cool air into the space to keep the space cool as the night goes on. And you can see here, you have your summer sun that beats down inside the space. They have a greenhouse. We'll talk about that in a little while. And if this floor was a earthen floor, it would also heat up and it would work as that purple wall.
So I have a question. That backside, are they built up that way?
This here?
Yeah, so you actually move the dirt into that mound?
Yes.
Okay, so it's not like built into a hillside.
So this is actually dirt, and I'm gonna talk about this in a little while. It's an earthen berm, and they put this on the north side of the wall in order to keep so that you're not getting any heat loss.
Gotcha.
So you have all this earth that's happening right here that's just preventing any kind of heat loss that would happen. And so this is the primary design that you'll see with all Earthships, if they're done the way they're supposed to be done, is that this the southern exposure, that southern wall, you have all the glazing and you have your solar panels, and we'll talk about renewables in a little while. You have the southern exposure with all of the windows here, and so you're capturing all of that heat gain into that space. And I'll tell you in a little while why that's important. Outside of the fact that you're able to capture all of that heat in order to keep the space up. All right, insulation. We're in Colorado. I know everybody here just loves to run outside when it's like 100 inches of snow outside, just naked, right? That's just like
From the hot spring, okay.
just yeah. You just love that, right? Anybody here would do that? Okay, we got one guy.
Well, I could snow in New York, Harold.
Not ready.
So what's the first thing that we say? We look out the window, we see there's snow outside. What do we have to do? Layer up. I need to put a jacket on. I need to make sure that I am insulated, because if I don't, I have a couple of problems when I walk outside in that snow. And so the way that you measure how well your insulation is based off of what's called R value. So the R value is the measure of your thermal resistance used in the building and construction industry. And it talks about how you're able to resist heat flow. And so it's measured by R8 to R32, and this is the amount of heat flow reduction. So an R8 wall will give you 90% heat reduction. An R32 will give you 97% reduction. So simply, it just means that the higher the R value, the greater the heat reduction. So that thermal, the ability for heat to pass through is reduced the higher your R value is. And the improvement in the energy efficiency, energy efficiency goes up as well, because you don't have, if you're heating that space on the inside, you're not losing that heat due to transfer. So one of the other strategies that they use, in addition to the earthen wall on the back, and I apologize for the graininess of the image. This is unfortunately the best image I could find to show the insulation that's installed on the backside of the wall. So they really seek to super insulate the building. So they have an earthen berm, and then they insulate it with rigid insulation on the backside. And that it provides that super insulation. So as I mentioned before, it's like the kid, rather than running outside with no clothes on, he's putting on down coat, quilt, Arctic level sleeping bag. And this is that earthen berm. So you were asking the question about the berm. So they pile the dirt on the backside. So as they build the wall up, they pile the dirt on the backside. So keep building, and then the dirt is built on top of that, and that it seals off to prevent the heat loss on that north side. Because again, no sun is going to be on the north side.
This is actually the front of the house, and it's that much buried. Everything behind that is buried.
Yes. So this is the front of the house, and everything else is on the back side. It just also depends on the design of the Earthship, but this is the basic organizing principle, that the front side of it, better yet, the south side of it will be full exposure, full glass exposure to the southern sun. Then you're entering from the east and west, and then on the north side, you're going to have an earthen berm in order to resist it. All right. So the other principle is solar and wind electricity, solar and wind electricity. Wind is not in every single one. Solar is the primary one that you'll find with Earthships. But renewable energy is an active system. It's an active system because it's a mechanically operating system. You have to have inverters. You have to have things in there in place in order to make it operate. So it's a little bit different than passive systems, because passive systems, all you do is, you don't have to do anything. It's going to operate. You're just getting yourself aligned with it. Whereas an active system, you have to put it in place. And so why is renewable energy important? Or is it?
Because we're past peak oil.
Because we're past peak oil. It's fossil fuels become a problem. So the idea that I can utilize a readily available source like the sun means that depending on the kind of technology that I'm using, whether it's the sun or the wind, once I have the instrument in place, the technology is in place, it's going to go ahead and do what it needs to do in order to produce the energy that I need versus not.
And it's far less polluting.
And it depends on how we look at it.
Yeah.
It depends. So it depends on the technology. So solar cells can be very polluting, but exactly. But yes, the idea that it's supposed to be far less polluting than fracking or drilling for oil. So one of the things that I thought was really amazing was how small the system was, 1.5, 2 kilowatts of the system. And so in order to understand what does that mean, I have a chart that just spells out our common appliances that we have around the house and the amount of energy that is required in order for them to be operated. So give me an appliance that you'd use today. Laptop. So a laptop, you're looking at 20 to 50 watts of energy usage that's being demanded. And so if you want to do an energy audit, if I'm going to have the laptop on, what else will I have on? Working on a laptop, what else am I doing?
Music.
I might have some music on. All right, so a video or DVD or CD, let's just say we're at 60 watts. So we're now at 110 watts of energy that's being used. What else would we might have at the same time?
The lights.
The lights. Well, lights depends on how many lights you have. 60-watt bulb times however many bulbs.
You got something on the screen.
Oh. You have a comment on the screen? No, I didn't say anything.
Is somebody tracking comments, by the way? Yeah.
Yeah.
All right. So let's just say while you're doing that, you get a call from your friend. Hey, let's go out, man. We need to go out. Have some fun downtown. So you say I have to iron my clothes because they're wrinkled. I don't know, they're wrinkled. So I pull out my iron, and I'm at 1,800 watts maximum with my iron, and I forgot to cut off my CD player and my laptop. So I'm starting to get up to the 1.5 to 2 kilowatts. And if you say, you know what, they might decide to come by my house afterwards, so let me go ahead and vacuum. Oh man, I just pushed us over. So we've just shut down our system or things aren't moving. All right. So that's the thing that's really powerful about it is that, this was the experience that I had being in there is that you become very conscious of the system that you're using. You're not just saying, what, electricity comes, it's going to be here and I'm just going to flick a light switch on, I'm just going to plug up, which we love to do. You become very conscious of your energy usage. So you become conscious of your water usage, you become conscious of your electrical usage in order to make sure that you don't exhaust it or you don't have any problems.
It's like the office we visited. Earthship office.
Exactly.
They had 3 days of clouds and the Earthship office was running off a generator.
Yes, exactly. The office has to stay operational. The guests, we got treated like royalty.
Oh yeah, we did.
But the office,
They're ironing like crazy. They're ironing like
can we exhaust this system? And so you see solar as one of the alternative energy sources, and you also have wind. And this was a wind turbine that Mike Reynolds designed. And so wind and solar come together in order to produce the energy that you're going to need generated, and then it's used within the space.
that building on the last where we gave our talk.
Yes. And so the amount of solar cells the array of solar cells that you have dictates how much energy you're going to be able to generate in order to operate as many appliances as efficient. Energy efficiency is something that's also extremely important. So as we talked about the thermal value of that space, by increasing your energy efficiency within the building, you also decrease the amount of renewable energy that you're going to need. So that's always the very first thing that you do when it comes to sustainable architecture, is that you figure out how to make my building as energy efficient as possible. Because logic just then says that I don't have to use as much renewable energy in order to do that. So how many of us remember standing outside as a kid, drinking that rain until our parents told us it was polluted, and then they tell us how they used to do it when they were kids. So rainwater capture. Rainwater capture is one of the other aspects. So water harvesting is another component that you find within the Earthship. Let's look at how much water do we use as a body of people. So as a single person, about 35 liters when we take a shower, 9 liters when we flush the toilet, about 25 liters when we drink a cup of tea or coffee. As a person, about 150,000 liters per year. How much we use if we are a family of four, we'd like to wash our clothes, 100 liters every time we use a washing machine. So how many people have washed their clothes this week? How many times? Anybody more than 2? One time? All right, so we've used 100 liters of water. How many showers have we taken? Today's what, Thursday? 2. All right, so we have 2 in the back. Very conservative.
Maybe 3.
Maybe 3.
Kind of a rugged town.
Yeah, I see.
It gets too dry here. It's not worth it.
Yeah, you're going outside, you're like that, man. The kid, pores are exposed. It's a big problem. So the value of capturing your own rainwater is just like the energy. You have to start tracking your water usage because you have a limited amount of water based off the size of your cistern. And the cistern is what the water is contained with inside. And so you have to really consider, do I need to really wash all those clothes? Yeah, what's a different conversation?
Do I need all those clothes?
Do I need all those clothes? Exactly. Exactly. When you start realizing how much water you're spending washing clothes, or better yet, exhaust all your water one day because you just had to wash all those clothes, you'll start cutting back on those clothes real quick. Maybe I don't need that favorite shirt that I thought was so favorite. And so when we think about as a household, the amount of water we use, as a toilet, just flushing, we're up about 24%. If we have a leak, that can be up about 12%. Washing clothes, about 17%. Taking a shower and just using the faucet to brush our teeth, we're up approximately 40%. So just taking the shower, good job, only 2 in a day, so you probably dropped that down to about 5%. So taking a shower and brushing your teeth, those are 2 major, and flushing the toilet, we have to use that. So between all 3 of these, we're looking up around 60% of water usage. And so it becomes important to manage that water usage because it's going to be problematic if in this case, if you're using it. So why are these numbers important? These are all the numbers that we don't think about every single day. Or better yet, in America, we don't think about it. Or better yet, in spaces where the infrastructure is in place, we don't think about it. We just hop in the shower and, I like that hot shower, so I'm gonna be in there for 20 minutes. Because I gotta wash my hair and I gotta wash my body, and it just feels so good on a cold day to be in that hot shower for 20 minutes. But you're using heat and you're using water, which in certain parts of the country, certain parts of the world, that's a commodity. That's a luxury. So how does the Earthship operate? Earthship Cap has a system of rainwater catchment systems that are integrated within the building. So rainwater will fall off of the roof and it will flow into whatever system they set up in order for that water to go into a cistern. And then it goes into the building. This is to maintain the pressure of the water. It goes into a filter. And then it goes into another filter. Then it goes into another filter, and then it becomes drinkable. And that's your gray water. So you have 2 different types of water. You have gray water and you have black water. Anybody know what gray water is?
Everything except for your toilet and maybe your sink.
Yes.
Depending on what you're pouring down.
Depending on what you're pouring in. If you're pouring anything organic in your sink, and if you've ever had to clean out a sink to rescue a wedding ring, then you will have experienced what gray water can look like, especially if it's a kitchen sink. Black water. So black water is anything that water is mixing with organic matter. So that's why the toilets are considered black water, and then a kitchen sink is generally considered black water. So what the Earthship does is it recycles rainwater, which is considered gray water, and it filters it, and it makes that drinkable. And it also takes that water and allows you to flush your toilets with it. So contained sewage treatment. This is another component. So they deal with on-site waste. They have an on-site wastewater management system. This is really, really awesome. It's an issue that we're dealing with right now in Alabama. We're looking to tackle. When we look at the percentage of the population with access to sanitation services, anybody here ever think about where they're going to use the bathroom? Most people are like, oh, I'm just going to go to the bathroom, right? Something we take it for granted. There are many places that don't take it for granted. It's kind of tough. Or you still got to go when you got to go, but clean sanitation is a problem for some places. In North America, 77.9% of the people have safely managed waste management systems. But if we go down sub-Saharan Africa, Latin America, and the Caribbean, Western Asia, and Northern Africa, up around 32.8% of safely managed. Then you're looking around basic, and then you have a good percentage that have limited, unimproved, and then open defecation. And so why is open defecation a problem? In Alabama, so Tuskegee University is in Alabama. The UN came down in December and toured America, actually, to look at poverty in America. They toured Lowndes County. Lowndes County is a county that's approximately 2 hours from our university, and they're suffering from issues dealing with hookworm. And hookworm, they're not dealing with cholera, but hookworm, cholera, and other diseases come as a result of poor sanitation. And what happens is that this is not something that we should be dealing with in America because we're in a developed nation, right? And so being in a developed nation, we shouldn't have to deal with this, but they're dealing with it. And it didn't happen when the UN came down. It's been happening for a very long time. And a lot of people are really upset because no one has been addressing it. And this is one of the things that has blew me away with Earthships, and why I decided this talk should be about Earthships, is because driving out there, if you think about the Earthship, if you don't put it in context, you just see this really creative system that you're like, why would you ever think to pound some tires with dirt and then live off the grid, But you're driving from here to through New Mexico to Taos. I realized the distance between the next nearest town is like 70 miles. And the distance between one town, the beginning of a town, and the end of that town might be, 5 seconds, literally, and you may actually go back 3 or 4 streets. All that means is that you don't have an infrastructure, but you have a lot of people that really want to live off the grid. They want to carve out a space for themselves. I'm not interested in a mortgage. I'm not interested in constantly fighting to live. I'm not, I feel like I'm living to pay somebody else to keep living. And so a lot of people are not interested in that. And so you can see the genius of what he was doing is saying, and he acknowledges it, that he wanted to create a solution that people who wanted to not have to deal with these issues could actually live off the grid and live in spaces, but wouldn't have to deal with sewer systems, would not have to deal with these temperature swings that you get out in the desert. And it's the desert, so it's not a lot of water. And we need water to survive, right? And so we realize that these are things that need to happen. And so the thing that's valuable about that is that him dealing with the wastewater is something that in Alabama, although we don't have the same conditions, we have issues with wastewater because we have a lot of people that are living without an infrastructure. And there are a lot of people around the world who are dealing with the exact same issue. So one of the other things about it is, let's see, we're here in Colorado, right? Right. All right. And New Mexico, it's up around 18% or more. They're in poverty. And it's more rural than the US average. So you're talking about basically an entire state that's very rural and it's very poor. And if we jump over to Alabama, we're dealing with similar conditions, similar economic conditions. So we're realizing that there's a socioeconomic issue associated with this. And so when you're coming up with this solution, it's really powerful because it's like, yeah, it was just done here in New Mexico, but he's been able to take it around the world to different places, because if you're dealing with a poverty issue or you're dealing with being in a rural area means you're separated from infrastructure. You're dealing with poverty issue means that even though I might have the infrastructure, I may not be able to pay for it, which is some of the things we're seeing. It's like, pipes run from the municipal services center to houses, but you know what? I'm a little bit further than their reach, and so I don't get access to that because I can't afford it. And so the solution that he developed is great because this is the challenge. And, sanitary systems is not something new. It's been around for a very long time. And despite how kind of graphic it is, it really explains what goes on. If I need to go to the bathroom because I don't have a bathroom around the corner, like right now I can say, excuse me, I'll be back, I need to go to the bathroom. I'm just asking you, where is it? But if I don't have that infrastructure in place, I'm gonna go to whatever place is private. And generally the private is not the space that I think is gonna be the cleanest. And so within that area, poor sanitation breeds disease. It's something we already know. But if I'm poor and I'm living in a rural area, although I may know it, I may not be able to do anything about it. Because all of us smart people in the room may not have come up with that solution. So that's what made, as you can see here, that then gets into your food system, it gets into your water supply, insects engage with it, and you're touching it, and all of that is making you sick. And these are the issues that we're seeing in parts of Alabama. And I know for sure these are some of the issues that are here in Colorado or New Mexico and any other rural area, poor area. We just haven't got somebody out there to research it. But better yet, that's what y'all do. And so if we think about the normal methodology for sanitation, what you do is you go to the bathroom, it gets contained, it gets pumped out if you have a septic system, pumped out, empty, transported, and it gets treated. And we get this nice thing called compost. So we can compost it and we can use it in order to grow vegetables. And that's what's really awesome about it, is because he's doing the exact same thing with his system. So we talked about gray water and what? Black water. And black water. So we have our gray water, which comes out of our sink. And then that gray water will go into a filter system, and then it will go inside, and we're going to talk about what happens when it goes inside in a little while. But then we have our black water. That's coming out of our toilet. So the black water will come here, and it will go into an underground tank where it will be treated. And then once it's been treated, it will be pumped out into non-edible plants. And so you have a decentralized system that for a person who's living in a poor area or a rural area that doesn't have access to the infrastructure, they're able to address that issue on site. And that's probably one of the most powerful pieces about this, is we all have waste, we have to get rid of it. And if I'm in a place where I don't have an infrastructure to deal with it, then I get disease. Yes?
Do they also have composting toilets there? Because I feel like in the desert, even that little amount of water to flush the toilet, it's valuable.
I didn't see composting toilets.
There is one Earthship I visited about 10 years ago that had a human manure system. And they were so confident in their ability to sanitize their manure through composting that they're spreading on their vegetable.
Yep, I've seen that too.
So Mike did tell us a really interesting story though about and maybe this is why they stopped doing it, about how a composting toilet at one point generated so much heat, and he had something flammable close to it that it started a house on fire.
Oh, wow.
Oh, wow.
Yeah, they heat saunas, some saunas in Sweden. with compost.
Is that like the methane coming out of it?
I think it's just from that chemical
It's just
process.
composting itself. I mean, composting is an awesome system. I mean, like for real. I mean, watching compost break down and the amount of heat that gets generated off of it, it's amazing because you don't do anything. I mean, it's a closed loop system. It's activated. You provide the right things, air, water, and fuel, and leave it alone. Maybe do a little tilling, and it gets hot. I mean, steam rises off of it. So I can definitely believe that's possible. That you got so much compost coming out of your compost toilet that it possibly overwhelmed your system. And you had to come up with a new solution. The thing that's really powerful about this real quick is that this is also, these are flushable toilets. And so if I'm looking at a system and I'm trying to engage with it, I need it to be as close to what I'm accustomed to, I'm used to as possible. Otherwise, I might think something about that. Particularly if we're talking about rural or poor, why are you giving me something that's different than what you have? Oh, because it's better. Prove it to me. You get it. Okay? So if you give me a system that operates just like I operate every single day, I go around the corner, I heard that there's these newfangled things called toilets that you press down a button and water comes down and pushes it out. Oh, I want those newfangled things too. So that means that we need to create systems that allow it to operate the way it's supposed to operate. And so that's really kind of what's really powerful about what he's created is it's the same kind of system. However, it's just a decentralized system. And that waste, the gray water that we talked about before, it flows into this space here. And so you have, when you walk inside of it, between, what side is this? From the southern side, between this space and this wall here, which are where your living quarters are, you have a greenhouse. And so all your gray water is flowing in order to be treated. And it's being dealt with by plants, so it's being dealt with biologically.
You don't have to plant any specific kinds of plants there to manage different types of nutrients.
He has bananas growing. He has a tropical rainforest in the middle of the desert. So I don't know that I can't speak to the selection, but I know I wouldn't have thought, let me plant a banana tree. I'm not sure if he's talked a lot about that selection.
There were very similar species of plants from greenhouse to greenhouse, but there were some like the Phoenix where there was no holds bar. But that also takes a team of botanists basically to come in there and manage it and to plant and to kind of monitor it over time.
So, and the condensation is crazy.
Yes.
So in a lot of these greenhouses, they'll design for a climate that you're trying to achieve. So if you're in USDA zone 3 or 4, like we are, you can step it up to USDA zone 10, which is like southern Florida. And then so you'd be choosing those plants based on the lowest temperature.
So in Taos I'm not sure what it is, it's like a zone 4, zone 4 or 5, and they're able to jump 6 zones, was what they were saying, 6 to 8 zones inside their greenhouses with that system.
And that's amazing.
So they're planting banana plants, which would be in Costa Rica, zone 10 or whatever.
Tropical, subtropical.
Yeah.
Yes. With snow outside, still growing bananas. And the black water is treated on the front in systems like this one here, or if it flows, maybe going to the rest of the tree that's here. So you're getting that it's being, that effluent that's once been treated in the septic tank, it flows out into non-edible plants to help those grow. So food production is the last one, and food insecurity is an issue that you find all over the world. So you go from high food security to very low food security. So at times during the year, eating patterns of one or more household members was disrupted, and food intake was reduced because the household lacked money or other resources for food. It sounds a lot like what you might have in a poor community, right? And so the fact that you're finding strategies, finding solutions within the home that will allow you to grow food, that's the thing that's also an amazing thing, because when we look around the U.S. food insecurity, 14% or more that have food insecure. Oh, there we go again. We're back into New Mexico. Okay, we didn't get to Alabama, but 13.9s and 14.4, tomato. It's still an issue. But we can also see that we're talking about a vast majority of the country that are also food insecure. So coming up with solutions that can address food insecurity, that's a kind of a really powerful thing to be able to do, say within a home.
What do you think? What is it about that? Okay, so California produces the most food anywhere, right? So is it, and then like North Dakota up there doesn't have food insecurity. What's going on? Great
question. So we can, I haven't dug into it, but you may be producing a lot of food, but that doesn't mean it's getting to the local communities. Mm-hmm. I may be producing food for someone in Europe. When was the last time you saw a banana tree in your backyard, yet you went to the store and bought a banana tree? So those are some of the political struggles that we find really all over the world. Particularly populations that don't have the political power or the capital in order to control their systems of production to ensure that it hits the people that are local before it hits the market. We are dealing with a lot of cash crops nowadays. Soybeans have gone way high, and so soybean farmers, there are farmers that are being paid to not grow edible foods because the cash crop is the soybean, or there is another cash crop that's out there. So they're not growing food for production. For consumption, they're growing food for production. And so without digging in, that would be how one of the rationales I'd say would be why you would have something like that. And then the prevalence of food insecurity between 2015 and 17. Again, New Mexico is bright red, and this map, Alabama, is bright red. So developing a solution that's local, but it's also continental, and then it becomes global. I didn't hit the global just because that's kind of a conversation we already know about. We don't really know about this conversation. We don't have this conversation. We make assumptions because we live in a developed nation that everybody is developed until we kind of drive out ways from materials. And so being in that space, and like I mentioned, you have oranges that are growing. You have bananas that are growing. You have so much vegetation growing, but you're kind of like, excuse me, goodbye, because it's just there, it's in your face. It's an amazing thing to be in the middle of the desert at the same time. And so this is a diagram that just shows how this whole thing works together. So we talked about the southern exposure, right? The southern exposure ensures that you're getting a heat gain. That heat gain is passing into the first greenhouse and the second greenhouse in order to grow food within the space. And then you're getting the comfort zone. These are living quarters. This is the living room and the bedrooms that are along this axis. And then you have the rammed earth tires that are also preventing the heat loss. Along with, you have your water cistern on this side that's capturing all of the rainwater that's flowing off of the roof, and you have your earthen berm that's encasing all of that and keeping down the heat loss. And so, in summation, when we're looking at sustainable architecture, in this case, I use the Earthships. Did I get it right?
What's that? The Earthships?
Yeah. I got it right?
Yeah, you did great, man.
Perfect. You're a resident expert. All right, cool. I got a hand clap. So I had the conversation about the Earthships because I figured this is something that's closest to you, that if you haven't been out there, I promise you probably should go out there and check it out. It's just like the coolest thing on the planet. To be in a space, I know it's not for everybody, but I think it's for everybody to see it because it really starts to challenge your mind of thinking what's possible in how you live. And to take a switch, I mean, as soon as we arrived and we put our bags down and we turn on the lights, immediately I'm thinking like, oh, I can't keep this light on, you know. I think about my mother's like, you leave the room, cut that light off. And so I'm like leaving rooms, hitting light switches and wondering why that's, I think I hit a switch, you hit a switch, and I hit a switch, you hit a switch. Like, you know, you're doing these things because you automatically become conscious about the environment that you're in and that there's a limited resource that I have to take advantage of. So when we think about issues around climate change, part of it is that if I'm separated from the supply chain, I don't really understand how limited it is. And then if I'm also I'm tapping other cultures or other spaces to meet the needs of developed nations, then they are close to the end of that resource, but I'm not close to the end of that resource. And so I can make an argument like there's not an issue. But here, you're all very familiar with a lot of issues, especially when you're dealing with mountaintops where the peaks aren't, you know, the peaks aren't as high as they used to be. The amount of snow that's being produced, the amount of ice melt, snow melt is not as great as it used to be. And you start getting wars over water. I mean, when you're at the ground level, you start to understand these things. And that's what's the great thing about what Mike Reynolds saw 30 years ago or 40 years ago, and what he implemented is that you can actually be in a community of over 70 plus homes that people are living in, and they're living off the grid in one of the most strenuous and challenging environments in the country. You're in the desert. I mean, we all know nothing grows in the desert. But when you can literally pick a banana off a tree, I mean, your house becomes an oasis in the desert. That's a powerful, powerful proposition.
I hate bringing this up.
Go for it.
I brought it up in class too, and it did you actually see any bananas?
I did.
Really?
Yes.
Nice
Yes.
big batch.
Yes. They were green.
Because in all the homes we toured, we didn't see any bananas, any oranges.
It was the model home.
Which one?
It was the model home.
It was
The global model. The global model.
Yeah. If you go past the offices and straight
Mhm.
back, that one's is for sale.
It was.
Okay.
They
So
recently
they
sold
must
it.
have gave it a lot of extra
I
love
also-
because even Mike said
Ellen
it's
has.
like no, almost none of those banana plants actually grow bananas. And
Well,
he made the sarcastic remark that's just for looks.
well, it is.
banana trees I don't think fruit very often
Yeah.
either. I think they fruit
Once every
like
9
maybe-
months.
Oh really?
Well,
I thought it was
we
like
did
once in
something.
their
We did something
lifetime or
right because
something.
there was a bunch of green bananas. Now they might have like glued it on there. So there was a bunch of green bananas.
I ate them. They're real.
Yeah.
I was kind of curious about water scarcity and being in a desert. Do they have any long-term plans for increased water scarcity? Or are they just gonna get more cisterns? I'm just kind
I mean, based on
Some people started to truck water out after last winter. The last winter is lower than the project. So they're saying that mountain range is going to be at 82% less snowpack by the end of the century.
wow.
82%?
Yeah.
They're experiencing
And so,
similar drought as us.
My friend James, who you met, he had to add another cistern, and that worked for a while. And then his last year there, he had a water truck come out, like broke his heart.
yeah, that would be.
So these
Right.
global models, typically, like from what I understand, a house that's the standard size, whatever that 1,500 square feet, 1,200 square feet is, they'll use two 1,750-gallon cisterns, and initially they'll come and they'll fill them. And so in the heavier precipitation years, that gets them through that initial flushing of that system or filling of that system will get them through. And because it's had drier seasons, now they're having to truck out water and refill those cisterns.
So we did see that extra water tank, remember?
Yes.
It was a solar pump. Sorry, Terry.
That must be why the city said they had to install
The couple of extra ones.
yes.
And that depends a lot too on occupants, amount of vegetation, how dry interior house is. If you have a bunch of landscape outside that you're trying to use that water for, and then you have a lot of evapotranspiration. So it really depends on how you're using that water, how efficiently you're using it as to how often you're going to fill it still. Some of them have washers, I know, I don't know which one you guys are in, but I was in Simple Survivor and it hadn't.
It had a washer and it had a nice sign that said, "Don't use it." This is for the housekeeping. So, I mean, at the end of the day, granted, what they're doing, this here is at the way into the spectrum. I mean, to do this, there's it's a total change in how you operate, things that you do. You really have to start to look at your lifestyle, change the culture of how you engage with space. But imagine taking just a few of these concepts and engaging them, whether even in your own lifestyle, decreasing your water usage just because you realize how much water you waste, say by brushing your teeth and keeping the water on, or cutting the lights off, realizing how much energy you're using because you keep the lights on as or using things at the same time, or how long is your shower? Everybody can't do 2 days a week, but hey, you might cut it down to, a 10-minute shower instead of 20 minutes of shower.
I'm married with tenure. I have the shower.
Don't worry, boy, it's all.
Less than twice.
Yeah.
That's the perks you get.
Yeah.
You have to shower now.
Aaron, what were you gonna say?
I was gonna ask where the name Earthship came from. Anybody know? Why is it called that?
Is it like the closed loop kind of idea?
I think Mike discussed the planet Earth as a ship floating. We're just all living on a ship, floating through space.
Okay, so it's that whole philosophy
Right.
scaled down.
Oh, don't get Kwesi started on bunkers for Fuller.
That's why I hesitate. That's why I hesitate to answer. So there's a futurist philosopher, architect, inventor, Buckminster Fuller. How many people, everybody's familiar with him?
Yeah.
If you have not, you got to check this brother out. I mean, he's not here no more.
I don't even work with so.
Oh, I mean, y'all got like 2 geodesic domes as you're going to Taos. I mean, Buckminster Fuller is gonna blow your mind away. I mean, combine him with Mike Reynolds, and you just get like an atomic bomb. I mean, just the understanding of where we are, and Fuller stated the same thing. That the Earth is a spaceship. It's traveling through space at the speed that it's moving. We talk about it rotates around the sun, and it's rotating on an axis. It's not static, and so it is a spaceship that's moving, and we're all occupants on the spaceship. And so the Earthship is the idea that I am taking the concept of the Earth as a whole and taking it to a very small level and saying I'm making it local as an individual and understanding how to live and operate on this ship, on called planet Earth. And by me operating properly on this ship, I will operate the rest of the ship properly as well. So that's the philosophy between the idea of the Earthship.
Does anybody out there in Oz have any questions? Like people that are far away. No, no questions out there.
I hit everything, huh? Blew you away? That blew you away? Awesome. How's it going?
I don't know, Meg, half of Meg's face looks skeptical. There she is.
I don't believe anything you're talking about.
I do have another question. This kind of goes back, relates to our trip to India. Dr. John, remember the biogas setup we saw?
Yeah.
So, there are several of these structures that are not off grid, in the sense that they use propane. They get propane trucked in quite a bit for their fuel needs inside their house, and especially their black water system and those tanks. I mean, you look at what we saw in India and how they were using that biogas. Seems like a perfect opportunity for them to use biogas as opposed to that propane.
Yes. So that's another. So I'm opposed to the conversation that treating methane just like CO2 emissions, because it's a gas that you can use to fire things up. You can supplant propane, you can supplant natural gas through composting. Composting produces methane. Going to the bathroom, we produce methane. You know, so rather than looking at it and saying it's a negative, you say, let me capture all of it that I can. There's a building in Chicago called the Plant. It's an old meat packing warehouse building, and they're composting a lot of the waste from the city of Chicago in a huge methane biodigester. And they're using the methane that's produced off of that to run, to operate the systems inside the building. And one of them is a bakery, So that's a real powerful thing about this conversation about sustainability is that, again, we go back to the beginning, it's closed loop. The minute you have waste, then there's an opportunity for an input. And you keep running that input until you run head to head with more waste, just like the free cycle. You're going to have all this waste because every student is not going to take all this. That's not a problem. That's a solution. I'm just looking for that solution. So what is that solution now? I'm looking for that new input that I can put this into so I keep that cycle moving. And that's where the fun of the space is. That's where the opportunity opens up for everybody, no matter what your discipline is. Because the minute you kind of throw a sustainability framework onto it, it opens up the realm of opportunities that weren't visible before.
Well, that's actually kind of perfect. That's been the whole theme of the class.
Awesome.
Like, let's flip this problem on its head.
Yes.
Like carbon's not a waste product. It's
No.
a raw material for every organism on the planet. So let's think about it that way.
Exactly.
I'm curious too, as he was talking through this, I was thinking about life's principles that we talked about last week. You guys remember that concept map of life's principles? Like how many life principles could we pull out of these designs? So we tried to go through like a checklist, and then where would the opportunities be where they might miss some of the life principles? I don't know. It's a tool from Maybe Green 3.8, but
Runs on sunlight.
yeah.
That's the first principle, right?
Yeah. There's like 26 of them, so it's not extra. It would be a thought experiment to work through,
Yes.
sometime. But
Yeah.
good.
Well,
Well, thank you so
woo.
much.
Thank you.
Good for seeing his first Earthship to complete lecture in 2 days.
Yes.
Record time.
Well, hey, that's the value of sustainable architecture. Once you see it, I mean, the conversations I had, it was just more validating. Like, this is what I understand. These principles, and as you're seeing, as he's exposing these things, I'm like, I get it. I'm finishing these sentences, or you don't need to say any more because it just makes sense.
Do you want just 90 seconds or 2 minutes on, for you, given the historical heritage of the campus, tied to Booker T. Washington, Robert Artero, the importance of this, and what you're trying to bring home to the campus and community, and for everyone here, there will likely be an Earthship built spring or summer down on the Tuskegee campus that we'll have a van load down there. Would you mind sharing some of that? I think it's important.
And let me just tack on to that question, and then maybe also tell us a little bit about the kinds of principles that were already in operation at Tuskegee long before that were progenitors to what we're seeing.
Definitely, and
So it's a full cycle.
And I'm not going to let Dr. Higgins be quiet in this as well, because Dr. Higgins is also an alum of Tuskegee, so he's a son of Booker T. Washington. So when we think about, so I come from Tuskegee University. We were founded in 1881, and we were actually an outgrowth of the community. The community said we want a school, and so we got a school. So I'll skip over some of the story, but we got a school. Booker T. Washington came down. He was the first principal. About a year later, he purchased an old plantation. There were 3 houses on that plantation, and they were in disrepair. That's what started our building process. And so he said, I had to fix this up. We had kids, students that came down that had, summers came, frostbite and rain. I mean, you think about the power of education. They tell stories of how students would hold an umbrella over his head so he could continue to give the recitation because they so valued the fact that he was bringing education to them. So we're talking about a population that is 20 to 30 years out of slavery. And so that you have a population that's already been socialized to not be educated, and now they're getting education, and that's gold to them. So a little rain, a little frostbite means nothing. But realizing that I need to provide housing, I need to provide space, tell our students, you can't complain. You didn't give you a shovel until you build your building. So get your book and do your studying. So we have a history of brick making. So we have an area called the Valley. It's where we dug up all the dirt, and we used that dirt and turned it into bricks. And we took those bricks and we built the buildings. And the faculty, we had many of the first African Americans to be in particular industries. So Robert R. Taylor, who our school is named after, there's an RR in front of the T-Sex. So Robert R. Taylor, he was the first African American graduate of MIT. He was also the first formally trained architect in the country. Anybody remember Valerie Jarrett? Valerie Jarrett, trumpet actor. Valerie Jarrett is his great-great-granddaughter. Just a connection. So Robert R. Taylor, he's credited with designing about 40 of the buildings on campus, and students built all the buildings that are there on campus. So there are about 60 buildings in total were built. We have about approximately 30 to 40 still remaining on campus. So we were a very sustainable campus. The story is that there's a book called Working with the Hands. You can find it on Google Books. I highly encourage people to look at it. It's Booker T. Washington tells the story how you get picked up at the train station, and the student would be picking you up, driving a horse-drawn carriage. The horse was cared for at the vet school, and the carriage was built by the students on campus. They would drive you onto campus into Dorothy Hall. Dorothy Hall was the original hotel. It would take you up to your room. The student would then present you with a menu of food items, and those food items were food that were grown on campus and printed on paper in the print shop, and the student would be wearing clothes that were tailored on campus, and you'd be staying in the building that the students built.
From clothes to shoes.
Yes.
We expect way too little from our students.
Yeah. We had a mattress factory, we had a sawmill, everything was produced on campus. And it was a totally sustainable campus. We were doing sustainability before sustainability was doing sustainability.
George Washington Carver's famous slide was made out of stuff from the garbage.
Yes. So, and Dr. Carver is one of our most famous professors.
See, I would say our challenge is, and this is probably going to be a conversation that I'd love to approach with you another time too, but how do you engage? How is your campus so willing to allow that type of applied education? Because I think about Western, think about our building codes here. To build an Earthship in Gunnison County, you're gonna spend years jumping through red tape.
Mm-hmm.
And so we just don't have the same pockets of freedom. Is Tuskegee in a pocket of freedom, or is it in an educational pocket of freedom where those opportunities for the students to build and learn with hands-on is just more at their disposal?
It's a navigation. We haven't explored what it looks like to do it yet, to run head-to-head with any challenges that may be out there. But we have land, and we do have the opportunity to say it's all research. So we can build. Building codes are there to protect the way building codes operate. They're there to protect the health, safety, and welfare of the public. As a resident, you can do whatever you want to do with your own house. Mm-hmm. So if you're creating a house, if we're creating a space, housing is a major issue in Tuskegee right now. So to do it, you just got to say you want to do it, and then you go through the steps to make it happen. Building codes still play a role, but there's a way to get around that. The other piece is that because of this history, it already opens a door to a conversation. So when Booker T. Washington was doing his work, his philosophy was learning to do by doing. You educate the head and the heart simultaneously. His belief was that every discipline that was going to be taught on campus was done out of natural order. So I don't teach you Latin. This is his words. I don't teach you Latin because the population I'm dealing with, Latin is not going to allow them. It's not going to give them a return on the investment. I'm dealing with farmers. Latin is not going to teach them how to grow, more food. So I'm not going to teach you Latin. I'm going to teach you agriculture, and I'm not going to teach you in a book when I can take you outside and teach you the exact same thing right there. I'm not going to tell you about a fish in a book, can tell you about a fish by going out there. So if you think about this conversation, his way we'd have this conversation is we'd be outside in Taos talking about Architecture 101 and sustainability, looking at the Earthship, talking about all the systems and how they operate. And so what he was doing then was considered monumental, and it's still considered monumental because we don't have a learning to do pedagogy with the way that we teach.
Mm-hmm.
So, but we're using that, and we're stoking our trajectory. We're stoking our trajectory in that history to say, I'm not telling you to do this. Dr. Washington said to do this. He did it, 150 years ago. Got a problem? We'll talk to him. You don't think it works? Then tell me something about these buildings that are still standing after 130 years.
So you're gonna go build one back in Alabama. I'm curious if you're gonna try to work to make these a little more affordable.
So that's a great question. So we had that conversation with Mike Reynolds. To become more affordable, there are a couple of trade-offs. If we do it the way he's doing it, it's very, very heavy labor. It's very labor intensive. Pound of brick. Seeing how many just for that wall. You got to find people that are committed. There's also the cost of land. Great thing is our land is cheap. I think it's about $5,000 an acre. So if you're looking at like $100,000 for a lot within the city limits, take that off and drop it down to $5,000. There's a lot more that you can do in that. And then in terms of materials, tires are we can find those very easily. Bottles we can find. So that waste is something that we can find very, very easily. And then the rest would just be galvanizing students, faculty, and visitors, and general public, and everyone at large. That here's something that's worth looking at, and that's part of the reason why we're looking to do it as a demonstration. As a demonstration, doing research, it affords you a certain opportunity to understand how the system works. And the other thing is this is something that's off the shelf at this point. You're looking at 40 years of research that's already been done. If you want to know how it works, just come to Taos and live in it.
Yeah, silver
Final thought.
I was just going to say silver lining in low socioeconomic is definitely the freedom to build, and you got your land, build however you want. Saw that in Taos.
Yes.
Thank you, Professor Daniels.
Thank you.